Welcome to Basic Electricity Tech TV, where we will be taking the mystery out of basic electricity. Hello and welcome. Welcome to another episode of Basic Electricity Tech TV. In this episode, we're going to examine some of the properties of parallel circuits. Stay tuned and thank you for watching. Okay, let's take a minute to analyze the circuit that we just viewed in the video. We know from our measurements that we were viewing, or we found 13 volts applied. We also measured 135 milliamps, and on branch number 1 we measured about 30 milliamps. And on branch number 2, we measured about 105 milliamps. Okay, that's all we measured right there. But we know from our study of parallel circuits that both branches are going to get the same voltage. So let's put those voltages in there. 13 volts and 13 volts, because both branches get the same voltage. At this point, we can calculate our resistances. 13 volts, 135 milliamps. We can figure out from using Ohm's law what our resistance is. So let's pull up our calculator. 13 volts divided by 135 milliamps means I have to put the decimal point first. 0.135 equals 96.29. We're going to round that out to about 96. 96. And just to keep things straight, I'll put the omega symbol in there to remember its resistance. So 13 volts, 135 milliamps, and we have a value of 96 ohms. I could go up here, 13 volts, 30 milliamps. Bring up my calculator again, clear that. 13 volts divided by 30 milliamps, 13 divided by 0.030 gives me a value of 433.3. And we're going to round that out to 433. 433. And again, let me put my omega symbol in. And the last one, 13 volts and 105 milliamps. Pull up my calculator again. We'll clear that. 13 volts, 13 divided by 0.105 gives me a value of 123.8. We'll round that out to 124. 124. And let me put in my symbol for resistance. And that's my table. Let's check this out now. We're going to use Kirchhoff's law of resistance. It's actually the law of resistance in the parallel circuit to determine if this is correct. So let's go ahead and do that. Clear that. 433, 124. Notice my total resistance came down to about 96 ohms. So let's calculate that. 1 divided by 433 equals, that's one value, plus 1 divided by 124 equals, that is the bottom half of my formula. I have to have 1 divided by that number in order to calculate my actual resistance. So I'm going to put that into memory. And then I'm going to go 1 divided by memory recall. And I get a value of 96.4, which gives me the same value. Let's round it out. So all of this seems to have worked, and everything else seems to have worked. The only column we can actually add correctly here is the amps column. Let's go ahead and do the power column. Clear everything out of my calculator again. 13 volts multiplied by 30 milliamps should give me the power in watts. 13 volts multiplied by 0.030 equals 0.39 watts. So we're going to put that in our table. 0.39 watts. Let me bring up my calculator again. Clear that. 13 multiplied by 105 milliamps. 13 multiplied by 0.105 gives me a value of 1.365. We'll round that out to 1.36. 1.36 watts. And let's clear that. 13 volts multiplied by 135 milliwatts gives me a value of 13 multiplied by 0.135 and gives me a value of 1.75 watts. Let's put that on our table. 1.75 watts. Okay, that's all of our values. Let's see if that adds up to correct. the correct numbers. 0.39 plus 136. 0.39 plus 1.36 gives me a value of 175 watts. And that's how I can check it. If these numbers add up to those numbers, it gives me a good value. And that's the way we analyze a parallel circuit.